Hello there, and welcome. Tonight, we're slipping past the edge, the event horizon, into the impossible. Beyond this boundary, time no longer marches forward. It stretches, slows, breaks apart. Yet within that darkness, there may be light, entire galaxies folded inside, universes nested like reflections in an endless mirror. Some say the universe we live in was born inside a black hole. If that's true, then somewhere, something out there might be falling into us right now. Prepare to meet the other side of everything. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now, take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. It begins with silence, an absence so complete it feels alive. Ahead of you stretches the edge of the universe's most perfect secret, the event horizon. There is no glow, no sound, no storm of matter screaming into darkness, just a smooth, impossible calm, as though the cosmos itself is holding its breath. The black hole waits, a hole in space-time so deep that even light cannot climb free once it crosses. Yet, in this stillness, gravity hums its slow, steady note, a lullaby of inevitability. You drift closer, and reality begins to bend. The fabric of space curves downward like a great invisible funnel, and everything around you starts to stretch, not through motion, but through perception itself. Time slows, unwilling to follow you where you are going. A clock on. Your wrist ticks faithfully, but the second hand seems lazy, reluctant, almost defiant. To an observer far away, it would appear to stop completely, frozen on the brink. But you are not frozen. You are falling. And the deeper you fall, the more the universe above you seems to accelerate, racing ahead as if eager to escape your fate. Colors distort into strange hues. Red light is dragged down, deepened until it fades from sight. Blue light, compressed by gravity, flares for a heartbeat and then vanishes. Ahead, there is only black, yet not the kind of black that hides behind closed eyelids. This is a living darkness, a boundary where the rules of existence fold in on themselves. You are about to cross the event horizon, the place where inside and outside lose their meaning. The moment you pass that invisible line, something profound occurs. There is no jolt, no impact, no flash of revelation. It feels almost peaceful, like walking through mist. Yet everything has changed. Behind you, space is forever sealed. No signal can escape, not even a whisper of light. You have slipped beyond the reach of the universe's memory. From this point on, all paths lead inward, toward the singularity, a destination not in space, but in time. The closer you approach, the more the arrow of time itself seems to warp. Every motion, every thought is drawn toward a single future. Around you, the laws of physics twist into poetry. The curvature of spacetime becomes so extreme that directions themselves unravel. Up and down, forward and back, lose their grip on meaning. If you shine a light ahead, it curves back toward you, like a faithful pet unwilling to leave your side. You try to imagine the geometry of this place, but your mind rebels. It is a landscape not of distance, but of destiny. The horizon behind you still glows faintly with the light of stars, though they now seem impossibly fast, streaking into red smears. Time outside is running ahead by billions of years. Galaxies are aging, merging, fading into the cosmic night. Civilizations rise and vanish in the time it takes for you to blink. To you, moments pass as usual, but the universe has already forgotten you. You are a ghost moving through the memory of creation. You fall, but not like falling through air. There is no wind, no resistance. You are simply following the natural flow of space-time, sliding along a curve that feels smooth and inevitable. The pull is not violent, it's graceful, like drifting down a cosmic river. If you could reach out and touch the fabric around you, it would feel both infinite and intimate, as though the universe itself were cradling you in its gravity. Somewhere beyond sight, the singularity awaits a point where all known physics collapses. Distances shrink to zero, densities climb to infinity. But that's not what your mind lingers on. You think about the idea that time and space could trade places here. Inside this strange realm, falling may not mean moving through space at all. It may mean moving through time, the way a drop of rain moves toward the ocean. You are not plunging down, you are being drawn forward, to an inevitable moment that already exists. Outside, an observer watching from a safe distance would never see you cross the horizon. To them, you would appear frozen at the edge, your image growing redder, dimmer, slower, until it fades entirely. You would become part of the black hole's shadow, forever suspended in their perception. But from your perspective, you are far beyond that now. Reality has split into two versions, one that stays behind, painted on the horizon, and one that continues inward, unseen. As you descend, you start to notice a faint glow within the dark. Not light in the normal sense, but a kind of shimmer energy, bending, echoing, swirling along invisible paths. Space itself seems alive, whispering secrets through the curvature. You realize that the black hole isn't a void at all. It's an engine. It consumes, but it also transforms. The matter it swallows is not destroyed. It's rewritten, its information compressed and stored across the surface of the horizon like a cosmic diary. The deeper you fall, the more the familiar world feels like a distant dream. The concepts that shaped your life, up, down, before, after, unravel quietly, like threads pulled from fabric. You begin to understand why physicists call this boundary the edge of forever. It isn't a place where things end. It's where meaning itself begins to bend. Space curves into time, time curves into mystery. And somewhere within that mystery, new beginnings might be hiding. You wonder what lies beyond the singularity. Some theories whisper that black holes could give birth to new universes, budding off like cosmic spores. In that case, perhaps your fall is not a death, but a crossing. Somewhere, on the other side, time could begin again, and the atoms that once formed you might drift into a new cosmos, unknowing but eternal. For now, you drift deeper into the unknown. The last light from the outside fades completely, leaving you surrounded by darkness that feels infinite but strangely serene. You sense no pain, no fear, only the vast, slow heartbeat of the cosmos echoing through you. Gravity's pull has become your pulse, its rhythm ancient and perfect. You are not separate from it anymore. You are part of the curvature now, a thread woven into the structure of space-time itself. If you could look back, you would see the universe still glittering at the edge of perception, blue worlds, golden suns, spirals of light slowly spinning. But they belong to another reality, another time. You have crossed into a place where time is no longer counted, only experienced. The edge of forever is not a wall, it is a mirror, and in that reflection you see what creation looks like from the inside. Gravity is often imagined as a force, a pull, an invisible hand that tugs on planets and stars. But the truth is stranger and far more beautiful. Gravity is not a force at all, it is shape. It is the quiet curvature of existence itself, the bending of space and time around anything that has mass. Every planet, every atom, every living thing presses a small indentation into the cosmic fabric, and that fabric responds by guiding everything else along its curves. The universe moves not because it is pushed or pulled, but because it is following the architecture of space. Imagine laying a heavy sphere on a soft sheet. The cloth dips under the weight, and any smaller objects placed nearby roll inward. That's the simplest way to picture gravity. But the truth is far richer, because the universe is not a sheet. It's a four-dimensional web of space and time woven together. The weight of stars, planets, and black holes doesn't just bend where things are. It also bends when things happen. Time itself stretches and contracts in response to mass. The more massive the object, the deeper the dip in spacetime's fabric. Near a black hole, that dip becomes so steep that it turns into a well with no bottom. This architecture is invisible, but absolute. Everything light, matter, thought must follow its curves. When a photon travels through space, it is not consciously bending around stars. It is simply following the shortest possible path through a landscape that is already curved. What appears to us as gravity pulling light is really geometry guiding it. The universe is not ruled by force, but by shape, by elegance, by the subtle folding of reality itself. If you could see this fabric directly, it would not look like a flat grid at all. It would shimmer and twist, alive with ripples and waves, stretching and trembling with every movement of matter. When a massive star explodes, space-time itself quivers, sending out waves that travel for billions of light years. These are gravitational waves, tremors in existence, messages, written in the geometry of the cosmos. When they finally reach us, their amplitude is smaller than the width of an atom, yet they carry the story of cataclysms beyond imagination. The universe is a symphony of ripples, each one born from the dance of gravity. In ordinary space, the curvature of gravity is gentle. It keeps Earth tethered to the sun, guides the moon across the night sky, and shapes the graceful spirals of galaxies. But near a black hole, the fabric of space-time is drawn so tight that it becomes almost vertical. The slope is no longer a hill, it's a cliff, smooth and infinite, plunging inward toward the singularity. If you could stand near that edge, time itself would run slower at your feet than at your head. The ticking of your watch would stretch, your heartbeat would lengthen, and the universe beyond would seem to race forward. You wouldn't feel the curvature physically, but every second would betray its presence. Einstein's equations describe this architecture with exquisite precision. They tell us that mass and energy are the same, and both sculpt the geometry of the universe. Even light, though weightless, contributes to this shaping. Every beam that passes through space leaves behind a faint, delicate wrinkle in space-time. Every particle you have ever known, every breath you've taken, has changed the shape of the cosmos, however slightly. The architecture of gravity is not something distant or abstract. It is the invisible design you live inside, the stage upon which all motion unfolds. Near a black hole, this design becomes art. The geometry here is so extreme that lines of space twist into loops, and time begins to curl back upon itself. If you could map it, it would look like a whirlpool frozen in motion, a spiral drawn into the heart of infinity. The orbits of matter around it trace delicate, perfect arcs, some stable, others doomed to plunge inward after countless revolutions. Even the light escaping from this region does not travel in straight lines. It swirls and bends, wrapping around the hole multiple times before escaping, creating echoes of the same star multiplied across the sky. To look at a black hole closely is to see space-time's architecture revealed, curved, luminous, recursive, alive. And this living geometry has memory. When a black hole forms, it retains the imprint of the star that collapsed to make it not in the way of a photograph, but as parameters: mass, charge, spin. The rest is stripped away, hidden beneath the horizon, as if the universe keeps only what matters for balance. Yet even here, at the edge of physics, the architecture remains consistent. No matter how massive, every black hole obeys the same elegant equations. Gravity does not discriminate, it only designs. Some scientists describe space-time as elastic, like a vast, stretching skin. Others see it as fluid, capable of flowing and eddying like water. Both metaphors are true in their own way. The fabric of the universe behaves like a living material, soft yet unbreakable, bending under weight but never tearing unless, perhaps, at the singularity, where all known geometry fails. There, the smoothness ends, and the structure collapses into something unknowable. Yet even that unknowable core might not be chaos. It might be the seed of new order, waiting to unfold. You are part of this architecture. Your body has mass, and that mass curves space-time ever so slightly around you. Every step you take reshapes the geometry beneath your feet. You are bending the universe, just as the universe bends you. The pull you feel toward the Earth is mutual. Your atoms tug on the planet, and the planet tugs on you. The dance is symmetrical, graceful, ancient. When you lift your hand, you are not fighting gravity. You are participating in its design. In the vastness of the cosmos, gravity builds structures on scales the mind struggles to grasp. It draws gas into stars, stars into galaxies, galaxies into clusters, and clusters into the filaments of the cosmic web. These filaments stretch across billions of light years, weaving a pattern that mirrors neural networks and river deltas. The same mathematics that describe the curvature near a black hole also describe the shape of the universe itself. Gravity, silent and relentless, is the artist behind it all. If you could stand outside reality and look down upon it, you would see not emptiness, but texture. A grand tapestry rippling with energy and light, folding and refolding like silk in slow motion. Every curve, every motion, every fall is part of the same pattern. Gravity's secret is that it does not pull, it persuades, it invites. Everything in existence follows willingly, tracing the paths carved by geometry, moving in harmony with the architecture of space-time. And somewhere, beyond the reach of sight, black holes serve as its most intricate designs, dark cathedrals sculpted from the very fabric of reality. From a distance, the fall appears to stop. A traveler drifting toward a black hole seems to slow, their movements stretching like syrup across time, until at last they appear suspended on the brink. Their ship hovers at the edge of the event horizon, haloed in faint red light, frozen in place. To the observer watching from afar, they will never see that ship cross the boundary. It will hang there forever, fading slowly, dimming until it vanishes, not because it was swallowed, but because time itself has folded against it. The closer it comes to the horizon, the slower its clock runs, until the flow of moments becomes almost imperceptible. The traveler, of course, feels none of this. Inside the falling ship, the seconds still pass with their familiar rhythm. Instruments hum, hearts beat, thoughts form and dissolve. To them the descent continues normally, the horizon drawing near in a quiet inevitability. But from the outside, those same seconds are stretched across eternity. The same motion that feels smooth and natural inside appears, from a distant frame of reference, as a gradual freezing of time. This paradox is not illusion. It is the geometry of space-time revealing one of its oldest tricks. Gravity bends not only space but time, and near a black hole, this bending becomes absolute. Light emitted from the falling traveler must fight against the immense gravity to escape. Each photon climbs the slope of space-time like a climber ascending an endless mountain, losing energy as it rises. That loss of energy stretches the light into longer and longer wavelengths, a process called gravitational redshift. To the observer, the ship's glow becomes redder, dimmer, slower, until even its final signals fade into invisibility. It's as if the traveler's last breath is still hanging there, endlessly delayed, an eternal whisper at the edge of forever. This phenomenon gives the strange impression that black holes never truly consume anything, that they are patient collectors, holding their prey in infinite pause. But the truth depends on perspective. To the traveler, the horizon is crossed in finite time. They pass through it seamlessly, carried forward by the flow of space-time. No sudden stop, no awareness of crossing a boundary. To them, the horizon is not a wall, but a one-way gate. Yet, to everyone outside, the moment of crossing never arrives. The two realities coexist, both true, both incomplete. The reason lies in the nature of time itself. We tend to think of time as universal, as if every clock in the universe ticks in unison. But near a massive object, that harmony breaks. Each region of space experiences its own tempo, dictated by how deeply it sits within the gravitational field. Closer to the black hole, time slows. Farther away, it races ahead. The traveler's seconds stretch longer than the observer's. A minute for them could span millennia outside. When gravity becomes extreme enough, that difference becomes infinite. From the outside, the fall takes forever, and so the illusion of stillness is born. But it's not truly an illusion. It's a conversation between perspectives. Space-time is a storyteller that changes its tale depending on where you stand. The traveler experiences a brief, graceful descent. The observer sees a long, endless one. Neither view is wrong, only incomplete without the other. The universe allows both to exist simultaneously. Two truths stitched into the same fabric. In the cosmic silence, this frozen moment becomes a kind of monument. Everything that falls toward the event horizon leaves behind a fading echo, an imprint of its last visible light. These echoes form the faint glow we sometimes detect around black holes, a blurred memory of stars and matter caught in perpetual slow motion. To the universe beyond, these ghosts linger indefinitely, marking the border between the knowable and the lost. If you could watch long enough, you would see entire histories unfold while that single ship remains unmoving, light stretching thinner with each passing age. There's a haunting beauty in that thought. The traveler, long gone beyond the horizon, continues to exist in the eyes of the cosmos. Their image is preserved, trapped in red light, eternally approaching but never arriving. From the observer's perspective, the universe has turned their final journey into an artwork of infinite patience. Time has not stopped. It has simply slowed until it feels like eternity. And somewhere inside that dark frontier, the traveler keeps falling. They see the stars behind them accelerate, blue shifted into a bright, compressed sky. The outside universe races forward in fast motion, galaxies colliding and fading as they descend. To fall into a black hole is to fall through the future itself, to witness eons pass in moments, to see the universe age and dim before the final plunge. For them, the crossing happens swiftly. For the cosmos, it never happens at all. This is the davrant paradox of the frozen moment, a single act that lasts forever. From the outside, the black hole seems almost mercifully still, a quiet sphere where time stands frozen. But deep within, the truth continues to unfold. The traveler's journey doesn't end. It simply moves beyond what the universe can see. In that unseen region, time reclaims its flow, and the fall goes on, silent and unbroken. The illusion of stillness is not a lie, but a boundary, a mirror reflecting both motion and eternity. To look at a black hole is to look at time itself holding its breath. At first, the fall feels gentle. The engines have long since gone silent, and there's no sense of movement, no rushing wind, no drag, no sound. The ship simply drifts, surrendering to the pull that no machine could resist. Outside the window, the stars appear steady, but their light has begun to twist in subtle, liquid ways. Space itself feels like it's flowing around you, not through emptiness but through something alive and responsive, like the current of an invisible ocean. Every motion, every pulse of light, bends slightly, curving toward the dark heart below. You are falling, but it feels like floating an illusion of peace draped over the most violent descent in the universe. The horizon below is not a line but a sphere, immense and silent, darker than any shadow you've ever known. It absorbs everything, even imagination. The closer you draw to it, the more the universe above begins to distort. The stars no longer twinkle. They smear into stretched arcs, like reflections on rippling water. The light of the cosmos begins to funnel, wrapping around the black hole in rings of impossible symmetry. You are looking not just at what lies behind you, but at the warped image of everything that has ever surrounded you, folded into a single, luminous halo. The entire sky curves into itself, and you feel as though you're being drawn inward, not just through space, but through realities. Reflection. Inside the cabin, the instruments lose their meaning. Clocks drift. Numbers crawl. The steady pulse of the onboard systems elongates, the rhythm of seconds dissolving into something fluid. You try to keep count, to tether yourself to ordinary time, but time has already begun to slip away. Every second inside the ship is no longer equal to a second in the universe above. If you could look back toward home, you would see your own past unfolding at impossible speed. Stars would age before your eyes. Whole civilizations might bloom and vanish in the time it takes you to blink. You are not just falling through space, you are falling through the future. The colors begin to fade, one by one. Red light is stretched first, then orange, then yellow, until even blue loses its brilliance. The sky becomes dim, as though the universe itself is sighing into sleep. The last light that reaches you is ancient and faint, a whisper from stars that no longer exist. And still, you fall. Gravity no longer feels like a pull. It is a directionless surrender, a slide along the curvature of spacetime. Every instinct that expects resistance, impact, or speed fails. You are motion without movement, descent without distance. Then something changes. The feeling of up and down, of direction, begins to dissolve. The geometry of space twists in on itself, and you realize that falling no longer means what it once did. The concept of movement assumes a reference point, and here none remain. You cannot tell if you are approaching the singularity or if it is approaching you. The dark below is not a destination. It is a horizon of inevitability that folds closer without ever moving. You've crossed into a realm where distance itself is unreliable, where the language of near and far no longer applies. If you could look out, your eyes would meet the strangest sight imaginable, the light from your own past orbiting around you. Photons that left your ship moments ago circle back, bent by the curvature of space-time, so that you see echoes of yourself from seconds before, ghosts of motion captured and returned. In every direction, space curves back into your gaze. The universe is watching itself through you, and you are both observer and observed. For the first time, you understand that gravity isn't just a pull, it's a conversation between matter and time, an endless dialogue that shapes everything and erases nothing. Inside your body, gravity whispers too. The pull at your feet is stronger than at your head, the difference stretching every atom by the smallest measurable margin. It's not pain, not yet, just a faint awareness that your shape belongs to gravity now, that your body is aligning with the flow of space-time. The descent deepens into surrender. You feel lighter, yet impossibly heavy, as though your very thoughts are being drawn toward the center. Every heartbeat feels older than the last. You are both ancient and new, falling toward a place where age has no meaning. You glance once more at the window. The stars above are nearly gone, their light captured and twisted until the sky itself seems to have folded shut. Only a faint halo remains, a ghostly ring circling the horizon, glowing like the rim of a dying sun. For a moment, it feels as though you are falling through that light itself, slipping between dimensions of brightness and silence. There is no noise, no vibration, no sign of motion, only the steady deepening of the dark. And yet, within that dark, there is a strange serenity. The fall is no longer frightening. It feels like returning to something you'd forgotten, like sinking into the memory of existence itself. Space around you softens into calm geometry. Time folds inward like fabric being drawn to a single point, and every thought becomes slower, clearer, quieter. You realize that falling without end does not mean falling forever. It means falling outside of time. The horizon behind you has vanished, and so has everything it once separated. You have crossed the threshold where moments no longer pass, where descent and stillness are the same. There is no up, no down, no before or after. Only the deep, silent curve of the universe carrying you inward, endlessly, into the heart of everything. There is a point in every fall where the body begins to understand what the mind cannot. The black hole's pull, once a silent and invisible current, begins to reveal its true nature. Gravity is no longer a gentle persuasion, it becomes difference. The nearer part of your body feels a stronger pull than the part farther away. The gradient is slight at first, almost imperceptible, but it grows with each heartbeat until the very shape of you begins to stretch along the axis of descent. It is not pain exactly, at least not at first. It is pressure, elongated and unrelenting, a reminder that you are no longer in the same kind of space you once knew. Tidal forces are what physicists call it, the uneven pull of gravity acting across a single object. On Earth, they are the reason oceans rise and fall, drawn by the moon's subtle tug. Near a black hole, that same principle becomes something else entirely. A sculptor of matter, a breaker of bonds. The pull on your feet could be thousands, then millions, then billions of times stronger than the pull on your head. No material, no alloy, no flesh can withstand it forever. Even atoms, those tiny fortresses of stability, begin to elongate, their clouds of electrons stretched thin like threads of silk drawn toward the abyss. If you could still look back, you would see your own ship or your own shadow drawn out like liquid light, thinning as it descends. The closer you fall, the more the difference in gravity expands exponentially, stretching every molecule into alignment with the direction of the pull. It is a process both terrible and elegant, a cosmic calligraphy written in the medium of matter. Every fragment, every particle, every photon obeys. The universe's geometry is absolute, and within it, form becomes surrender. From the outside, no one ever sees this happen. To a distant observer, you remain at the edge of the event horizon, suspended, frozen in red light. The image of your body, distorted and fading, hovers there forever, never crossing the boundary. But within your own frame of time, everything continues. The horizon is behind you now, invisible and meaningless. The fall is absolute, and so is the transformation. The further inward you go, the less your sense of self can keep pace with the shape of reality itself. The experience of spaghettification is not sudden. It is a slow revelation. First, the awareness that your limbs are no longer aligned with any clear direction. Then the feeling that your body's boundaries have begun to loosen, the distinction between part and whole dissolving. The line between being stretched and simply existing becomes unclear. You are pulled thinner, yes, but also wider, as though you are expanding along the fabric of spacetime. Your consciousness begins to slip, not from pain, but from the sheer vastness of the transformation. You are being unmade, but not destroyed, reorganized according to gravity's final design. At some point, distance loses meaning altogether. Every atom that once belonged to you becomes part of a stream of matter spiraling inward, following a curve so steep that space and time themselves trade places. You are no longer falling through space. Space is falling through you. What you once thought of as descent has become flow, the motion of geometry itself carrying you forward. The energy of your disassembly becomes part of the whole's growing mass, and with that addition, the horizon expands outward ever so slightly, the universe adjusting its balance. And yet, within this violence, there is grace. The equations that describe what's happening to you are precise, elegant, and silent. Gravity's strength is brutal, but its structure is pure order. The same forces that tear apart stars also sculpt galaxies. The same mathematics that stretch you thin also weave the fabric of everything that ever was. You are not dying in the ordinary sense. You are becoming part of a larger curvature, an extension of spacetime's own motion. Every elongated atom, every pulled strand of energy contributes to the symmetry of the whole. If you could see beyond the limits of your perception, you would find that this process is universal. Stars, gas clouds, fragments of worlds all undergo the same stretching as they approach the singularity. Each is reduced to a filament of energy, spinning in tight spirals as it disappears from sight. These filaments form the innermost structure of the accretion flow, swirling like threads of light drawn into infinity. The black hole does not consume them in chaos, but in perfect order. It accepts, arranges, and preserves the energy they contain, compressing it into a deeper and deeper curve of space-time. In that realization lies a strange calm. The fear of destruction fades, replaced by a sense of inevitability so vast it feels sacred. You are not separate from the forces that act upon you. You are their expression. The same gravity that holds galaxies in place is now shaping your final form. The moment when your body finally reaches its breaking point is not an end, but a transition, a merging with the geometry that governs everything. In a way, this is the purest form of unity the universe allows. The last thing you might notice, before awareness itself is stretched too thin to hold together, is light. Not from the stars above, which have long since vanished, but from within the faintest shimmer of energy still clinging to your atoms, a final radiance drawn out into a filament so thin it borders on nothingness. It flickers once, like the afterimage of existence, then fades into the curvature. You have become part of the flow, one thread among countless others in the dark tapestry that gravity endlessly weaves. At the heart of every black hole lies a place no equation can fully reach, the singularity, a point so dense, so absolute, that the familiar scaffolding of physics collapses under its own weight. It is the center of the abyss, the destination of everything that crosses the horizon, and yet it is also the one place our understanding cannot follow. Here, space and time are no longer separate threads. They are drawn together, twisted into a knot, so tight that neither can be untangled from the other. It is not simply a location, but an ending, or perhaps the beginning of something else entirely. From a distance, the singularity is only a word, a mathematical conclusion, the point of infinite density. But infinity is not a number. It is a confession. It is the moment where human language breaks down, where math turns into metaphor. We can trace the descent of matter all the way to this boundary, describing every step with the precision of Einstein's equations, until suddenly the map dissolves. The line we've been following doesn't stop, it just ceases to make sense. The coordinates no longer correspond to anything we can picture. Geometry itself has vanished. If you could see it, which you cannot, it would not appear as a dot or a burning core. There is no light, no color, no surface. What we call a singularity is an absence wrapped in curvature, the place where every direction becomes inward. Inside it, the very idea of space loses meaning. There is no where left, only the collapse of when. Every event that falls toward it is drawn not into a place, but into a moment, one final instant stretched across eternity. The entire history of the black hole, everything it has ever swallowed, exists together here, compressed into a single unending now. The paradox lies in what that means. According to general relativity, this collapse should continue, without limit. Density rises toward infinity, volume shrinks to zero, and space-time curves until it folds in upon itself completely. But quantum mechanics refuses to agree. It whispers that there must be a smallest scale, a limit to compression, a grain to the fabric of the universe that cannot be crushed beyond a certain point. Somewhere, deep within that contradiction is the truth, the place where gravity and quantum rules are meant to meet, but have not yet shaken hands. Until they do, the singularity remains the universe's most intimate secret. Inside the event horizon, You would have no warning that you were approaching it. There is no boundary, no flash, no wall of fire, only an intensifying curve. Every direction becomes the same direction forward in time, deeper toward the core. The singularity is not ahead of you. It is your future. In that sense, it's not a place you fall into, but a moment you inevitably reach, the final tick of a clock that has been running since your first step across the horizon. And yet, paradoxically, while your time ends there, the universe outside continues forever. From the perspective of distant galaxies, you never quite vanish. Your image, red-shifted and fading, remains etched on the black hole's surface. In one frame of reality, you are gone. In another, you are frozen at the edge. This duality, the coexistence of disappearance and endurance, is part of the singularity's enigma. It swallows everything, and yet, somehow, it leaves a trace. Physicists have long wondered what truly happens at this core. Some believe that gravity compresses matter beyond recognition, reducing all information to nothingness. Others suggest that information cannot be destroyed, that it must survive, encoded somehow within the structure of spacetime itself. Perhaps it is stored on the horizon, like the imprint of a fingerprint pressed into glass. Or perhaps the singularity transforms it, sending it forward into another reality entirely. If every black hole hides a singularity, and every singularity obeys the same mathematics as the Big Bang, then maybe our universe began this way from inside one such collapse, born from the death of another world. The mind struggles to imagine such continuity because we are creatures built to live inside time. We know beginnings and endings, cause and effect, but the singularity dissolves those boundaries. Inside, there is no before or after, no distinction between faller and fallen. Everything is one, compressed into perfect simultaneity. It's as if the universe, in its deepest layers, prefers unity to order. If you could somehow survive the descent, if there were a way for consciousness to persist within that infinite pressure, you might feel something like merging, not destruction, not pain, but the dissolution of individuality. You would no longer be a body or even a sequence of moments. You would be part of the curvature itself, a ripple in the pure geometry of being. To exist within the singularity would mean to exist everywhere and nowhere at once, to be folded into the same breath as all matter and energy that ever was. It would be the ultimate intimacy, the purest convergence. But we cannot know. The equations stop here, the instruments fail. Every attempt to peer beyond returns silence. The singularity is the universe's own horizon, the edge of comprehension. Some think of it as a flaw, a tear in the fabric of the cosmic design. Others suspect it is deliberate, a boundary meant to remind us that even infinity has structure. The closer we come to understanding, the more the mystery deepens, and the more the paradox begins to resemble a mirror. For perhaps the singularity is not only a place where physics ends, but where questions begin again. Perhaps it is not a grave, but a seed. In the stillness, at the center of a black hole, everything that was ever separate becomes one. Space folds into time, time folds into mystery, and, in that perfect, silent compression, the universe holds its breath, waiting, maybe, to be born again. Imagine for a moment that the end of everything might also be a beginning, that within the absolute darkness of a black hole, something new could take shape, a universe born from the ashes of another. The idea sounds almost mythic, like something whispered by the cosmos to comfort itself. But among physicists, it has another name. The universe, seed hypothesis, is. It suggests that every black hole might not be a tomb, but a womb, a place where the collapse of one reality gives rise to the birth of another. At first glance, it seems impossible. A black hole, after all, is a region where even light cannot escape, where all matter and energy are crushed into unimaginable density. It is destruction incarnate. But deep within that destruction lies the singularity, the point where space-time folds to infinity and the known laws of physics dissolve. When we reach that edge of understanding, we find an unexpected symmetry. The equations that describe a collapsing star are eerily similar to those that describe the birth of a universe. Both involve an explosion or implosion of energy into spacetime. One runs backward in time from the other, like mirror images. If the Big Bang was the expansion of everything from a single point, a black hole could be that same process in reverse, funneling one universe's matter into the seed of another. To picture this, imagine spacetime as a vast sheet and a black hole as a tunnel punched through it. To us, it appears as an endless pit, but on the other side of that tunnel could be an outflow, a white hole, where everything that was consumed is expelled again, reassembled into a new beginning. In this view, the singularity is not a dead end, but a bridge. The event horizon becomes not a wall, but a membrane dividing parent and child universes. What falls in here might blossom elsewhere, in a dimension that curves away from our own. It's an idea that blurs the line between science and poetry. Some cosmologists, following the work of Lee Smolin and others, have proposed that universes reproduce through this process. Each black hole could give birth to a new universe with slightly altered physical constants, a different balance of gravity, electromagnetism, and quantum behavior. Over time, those universes that produce the most black holes would naturally create more offspring. It is a kind of cosmic evolution, selection not by survival, but by creation. In that sense, we might live in a universe that exists precisely because its conditions favored the birth of new ones. We are, perhaps, the descendants of a long lineage of collapsing worlds. Inside that framework, the singularity becomes a seed. Every black hole carries within it a hidden potential, the compressed essence of everything it has devoured. The matter and energy that disappear beyond the horizon are not lost, but transformed, condensed into the initial conditions of a new space-time. On the other side, that seed may erupt in a big bang of its own, expanding into a realm that to its inhabitants feels infinite and self-contained. To them, it would be their entire cosmos. To us, it would be invisible, sealed behind the veil of gravity. If this is true, then creation is not a singular event, but an ongoing process, repeating across scales we cannot perceive. Each universe births its successors through collapse, and each successor inherits a trace of its parent's structure. There could be countless universes nested within one another, connected by the invisible throats of black holes like pearls strung along an infinite thread. Our universe, with all its galaxies and stars, could simply be one bloom in an eternal cosmic garden. It's a humbling thought. Every star that dies and collapses might be planting the seed of another universe. Every flicker of light, every atom drawn into darkness, might go on to become part of something vast and new. The energy that once burned in our skies could ignite entirely new realms of time and space. Even the end of our own universe, the moment when all matter collapses into the final black holes, might not be an extinction, but a transformation. The darkness that consumes us could also be the soil from which other universes grow. Of course, we have no way to see beyond the event horizon. Whatever happens within remains hidden from our instruments, sealed by the very laws that describe it. Yet, the mathematics keeps whispering its possibilities. The symmetry between collapse and expansion is too elegant to ignore. It's as though the universe is hinting at a deeper continuity, one where beginnings and endings are not opposites, but reflections. If universes can be born within black holes, then perhaps our own universe was born the same way, from a singularity at the heart of another reality, its matter and energy spilling outward into this one. That would mean that every galaxy, every life form, every thought that exists here is part of a cosmic genealogy stretching back through uncountable generations of universes. It would mean that creation never ceased, it only changed form. Somewhere, perhaps right now, a massive star is collapsing in a distant galaxy, its core imploding under its own gravity. From our perspective, it dies, consumed by its own weight. But beyond the horizon, its fall may not be an ending at all. Its energy could already be blooming into a newborn cosmos, its own vast sky of stars, its own laws of physics, its own timeline unfolding. Somewhere within that new universe, another consciousness may one day look up at its night sky and wonder how it began. And maybe, just maybe, it will feel a faint echo of this one, the memory of light from a world that once lived before its birth. If black holes are the universe's way of swallowing, then white holes are its imagined way of breathing out. They are the mirror, image of collapse, a cosmic exhale, a phenomenon that reverses gravity's grip and pushes everything outward instead of drawing it in. Unlike their dark counterparts, white holes are said to reject matter, not accept it. Nothing can enter one, everything is expelled. They are the ultimate reversal, where the arrow of time seems to point the other way, and where creation bursts from the same geometry that once devoured light. No one has ever seen a white hole. They exist only in theory, mathematical ghosts born from the same equations that gave us black holes. Yet, their logic is strangely irresistible. If the universe allows one extreme, a place where space and time fold inward infinitely, then perhaps it allows the opposite too, a region where time runs backward, where matter and energy erupt from a point of infinite compression and rush outward, not into darkness, but into the light. In this way, a white hole is not destruction's twin, but its reflection, the other face of the same cosmic coin. To understand a white hole, imagine turning a film of a black hole inside out. Every falling star, every fragment of light plunging into the event horizon now reverses, erupting outward in a flood of motion and brilliance. In this reversed world, gravity still rules, but its will is inverted. The closer you come, the stronger the push away. The event horizon is not a gate of no return, but a barrier of no entry. Space itself accelerates you outward, refusing all intrusion. Matter that emerges from this region is not lost debris, but reborn energy, cleansed of its past trajectories, its history erased by the physics of reversal. Some theorists have suggested that white holes might be what we experience as cosmic explosions, brief, violent bursts of energy with no apparent source. The universe is filled with such mysteries, gamma-ray bursts, quasars, flashes that outshine entire galaxies for moments and then fade into silence. Perhaps, some have wondered, these are glimpses of the other side matter ejected from a white hole's mouth, the final act of a process that began long ago inside a black hole's heart. If every black hole is a door, maybe white holes are the rooms that open beyond them. The idea is deeply symmetrical, and the universe loves symmetry. In the equations of general relativity, black holes and white holes can coexist, connected through bridges called Einstein-Rosen tunnels, wormholes that thread between realities. In this view, a black hole's singularity is not a point of termination, but a passage. Everything that falls in does not disappear, but re-emerges elsewhere, expelled from a white hole in a different region of space, or perhaps in a completely separate universe. The two together form a loop, a continuous flow of matter and time, folding reality into itself in ways that feel more like dream than physics. If this is true, then every act of falling is also an act of creation. The matter consumed by a black hole could one day surge outward through a white hole, born again into expansion. The death of a star here might be the birth of another sun elsewhere. Even the Big Bang, the great beginning of our own universe, fits this pattern almost perfectly. For what is the Big Bang, if not a white hole on a cosmic scale? A single moment when energy and matter exploded outward from a point of incomprehensible density, filling space with time, light, and possibility. It may be that our entire universe is the outbreath of a collapsing star in another. It is a comforting symmetry to imagine, creation and destruction bound together in endless alternation, each giving rise to the other. The universe could be a perpetual rhythm, a heartbeat of contraction and release. Every black hole's silence balanced by a white hole's eruption, every fall answered by a surge of new light. If so, the cosmos is not dying or expanding aimlessly, it is cycling through itself, forever regenerating, forever beginning again. But white holes, if they exist, would not last long. The physics that creates them would make them unstable. Their furious outflow of energy would tear at their own foundations, burning brightly and vanishing quickly. They would live and die faster than the blink of an eye, scattering their contents across space. Their existence would be almost impossible to capture brief, brilliant pulses lost in the vastness of time. Perhaps that's why we haven't seen one. Perhaps we already have, but only for a heartbeat too short to notice. Even so, their theoretical presence leaves a mark on how we understand everything. The idea of white holes turns the story of black holes inside out. It tells us that even in the deepest collapse, there might be potential for expansion, that even in endings, there is the blueprint for creation. It's the universe's quiet reminder that opposites do not destroy one another, they complete the pattern. If you could stand at the threshold of a white hole, you would see time itself moving away from you. Everything would be rushing outward. Light, space, the fabric of reality streaming past like a great tide. You wouldn't fall in, because falling would be impossible. You would be pushed outward, carried on a current of pure energy toward the birth of something new. And as you drifted away, you might realize that every beginning in the cosmos, including your own, might have started just like this, with a great, luminous refusal to collapse. At first glance, a black hole seems like the ultimate perfection of darkness, an object so absolute that nothing can escape its pull, not even light. For a long time, this was how we understood them, as silent, eternal prisons where matter vanished forever, leaving only gravity behind. But in the strange and delicate realm of quantum mechanics, nothing is truly absolute. Even the void is alive with activity. Empty space is not empty at all. It shivers with invisible fluctuations, particles and antiparticles appearing and vanishing in pairs, their existence measured in moments too brief to imagine. And it was in this restless quantum sea that a quiet revolution began, one that would forever change how we saw the black hole's edge. Stephen Hawking first glimpsed it in the mathematics, an impossible whisper of light escaping from the unescapable. According to quantum theory, space around the event horizon seethes with virtual particles, pairs of opposites born from pure energy. Normally, they annihilate each other almost instantly, returning what they borrowed from the vacuum. But near the edge of a black hole, something extraordinary happens. Gravity splits them apart. One falls inward, the other escapes. To the universe outside, that escaped particle becomes real, a faint flicker of light, a breath of radiation from a place that was supposed to be silent. This emission is what we now call Hawking radiation. It means that black holes are not eternal after all. They evaporate very slowly, shedding their mass in a drizzle of quantum energy until, after eons beyond comprehension, they fade into nothing. The black hole, once thought to be a perfect one-way door, is quietly leaking its secrets back into the universe. Even the most absolute darkness glows if you wait long enough. The mechanism is subtle but profound. The escaping particle carries away a fraction of the hole's energy, which means its mass decreases. As it shrinks, its surface temperature rises. A large black hole emits almost no radiation, its temperature hovering near absolute zero. But a smaller one glows hotter, radiating more intensely. In its final moments, it would burn brighter than 1,000 suns, a flash of annihilation that marks both an ending and a release. This slow undoing of the universe's most mysterious objects is not a tragedy. It's a kind of balance. The cosmos, it seems, does not allow anything to keep its secrets forever. At the intersection of relativity and quantum mechanics, this discovery is a bridge between opposites. Einstein's gravity describes the smooth, curved geometry of spacetime, while quantum physics speaks in probabilities and particles, in the restless jitter of the microscopic world. The event horizon is where these two languages collide. General relativity insists that nothing can escape. Quantum mechanics insists that uncertainty can never be silenced. In that collision, the black hole becomes something stranger than either theory alone can describe. It becomes a paradox made of light and gravity, a shadow that glows at its edges. The radiation itself is unimaginably weak, far beyond our ability to detect directly. If the sun were replaced by a black hole of equal mass, its Hawking radiation would be colder than the faintest cosmic background. And yet, in the mathematics, it hums softly, like a ghost frequency in the dark. Over time, that whisper changes everything. It means information might not be lost after all, that the universe, even at its most destructive, might still obey the deeper rule that nothing is truly erased. Physicists call this the information paradox. If everything that falls into a black hole eventually escapes as radiation, then where does the information go? How does the universe keep track of what once was? Some suggest it's stored on the event horizon itself, imprinted across its surface like a cosmic archive. Others believe the information is scrambled into the radiation that leaks away, too complex for us to ever decode. And some suspect that both ideas are true, that the boundary of the black hole is not a surface in the usual sense, but a hologram of all that lies within. In this vision, reality itself is layered. What we perceive as volume may only be a projection, a shadow cast by information written on the edges of existence. The thought is dizzying, yet beautiful. It means the universe could be fundamentally self-aware, recording everything that ever happens, preserving it not in memory or matter, but in structure. Even the act of falling into a black hole might not be the end of a story, but its translation into a different language, the language of quantum shadows. Hawking's insight did more than reveal a physical process. It changed the philosophy of the cosmos. It showed that even in the most extreme corners of reality, the rules remain consistent. Gravity may bend light and time beyond recognition, but quantum uncertainty still finds a way to whisper through. In a sense, the black hole's darkness is not silence, it's a low hum, the universe singing in frequencies too faint for us to hear. And somewhere in that hum, there is a lesson about existence itself. Everything that is born will someday fade, yet in that fading lies transformation. Even the heaviest, most secretive object in the cosmos cannot hold on to its mass forever. It will give itself back, one particle at a time, until the last flicker escapes into the cold and the curve of space-time flattens into quiet. What remains then is not emptiness, but equilibrium, the perfect balance between what was consumed and what was released. In the end, Hawking radiation reminds us that nothing is absolute, not even the void. Every shadow glows a little at its edge, every silence hides a vibration, and even the darkest places in the universe are, in their own quiet way, still trying to shine. The universe does not forget. Every atom, every flicker of light, every thought that has ever existed leaves a trace written somewhere in the fabric of reality. Even when matter is torn apart, when stars collapse and vanish into black holes, the information they carried, the fundamental arrangement of their particles, their spin, their energy should, by the laws of physics, endure. Yet black holes seem to challenge that promise. They swallow everything: matter, light, data, history. From the outside, nothing ever escapes. And if the black hole evaporates through Hawking radiation, leaking energy until it disappears completely, what happens to all that information? Does it die? Can the universe allow such a loss? Stephen Hawking once suggested that it could. According to his early work, black holes destroy information forever. What falls in is erased, replaced only by the faint thermal glow of Hawking radiation, pure heat, devoid of pattern or meaning. But this idea sent shockwaves through physics because it broke one of nature's deepest rules. Quantum mechanics insists that information cannot be destroyed. Every interaction, every transformation in the universe is reversible in principle. To lose information would be to tear a hole in the logic of reality itself, a kind of cosmic amnesia. It would mean that the universe is not a closed system but a sieve, leaking memory into the void. Physicists called it the information paradox, and for decades it stood as one of the greatest riddles in science. On one side, general relativity painted black holes as perfect prisons, smooth, featureless regions where all distinctions vanish. On the other, quantum theory demanded that every detail of what fell in must persist somehow. These two visions, both true in their own realms, refused to coexist peacefully. Somewhere at the heart of the paradox, between geometry and probability, between space-time and uncertainty, was an answer that neither theory could reach alone. Over time, the idea that information truly dies began to crumble. Subtle clues emerged from the mathematics of quantum fields, from holographic theories, and from string theory's intricate symmetries. Physicists began to suspect that the event horizon, the boundary of the black hole, was not as passive as it seemed. It might act as a vast recording surface, encoding the information of everything that falls in, not lost, not destroyed, but written in a form we cannot yet decipher. The black hole, in this view, becomes the ultimate hard drive, compressing data to unimaginable densities, preserving it at the edge of oblivion. This idea gained strength through a principle called holography, the notion that all the information contained within a region of space can be represented on its surface, much like a hologram stores a three-dimensional image on a two-dimensional plate. The black hole's event horizon may be such a surface. Every photon, every particle that crosses it, leaves a faint, encoded signature. From the outside, the hole looks smooth, but hidden within its quantum structure could be the entire history of what it has consumed, stored as subtle vibrations of space-time. In this way, a black hole does not erase information. It rearranges it, disguises it, hides it within the curvature of its skin. It's a strange kind of immortality. What falls in is never seen again, yet its essence endures, woven into the black hole's growing surface. As the hole radiates and slowly evaporates, that information may leak out again, embedded in the pattern of Hawking radiation. The process would be unimaginably slow and complex, so tangled that to decode it would take longer than the age of the universe. But in principle, the data is still there. The universe keeps its books balanced. Nothing is ever truly lost. It's only hidden in forms too intricate for us to read. If this is true, then the surface of a black hole is not an end, but a translation. A place where the language of matter becomes the language of geometry. The atoms of a fallen planet, the light from a dying star, even the faint patterns of thought from a conscious mind could all become part of that encoded surface. To the black hole, every memory is equal, an imprint of energy on the curvature of space. Perhaps, in a sense, everything that has ever fallen into a black hole still exists there, preserved in that dark, silent ledger written by gravity. This perspective changes how we see the cosmos itself. It suggests that the universe might operate as a grand information network, a web that records everything, no matter how fleeting. Every interaction adds to the archive. Every decay, every collapse simply transfers data from one form to another. The stars, the vacuum, the black holes, all of it might be computation, a vast processing of existence. Even we, with our fragile bodies and temporary thoughts, are part of that exchange. Each moment of awareness, a calculation written in light and energy. The paradox, once seen as a problem, now looks more like a clue, a sign that our two greatest theories are fragments of a larger truth. Somewhere beyond them lies a unified picture where space, time, and information are the same fabric, woven together by rules we've only begun to glimpse. The black hole, rather than being the end of knowledge, may be its purest expression, a reminder that information, like energy, cannot vanish. It only transforms. And so, even in the cold silence of a black hole, where light itself surrenders, the story continues. The universe keeps its memory intact. What is devoured is not forgotten. What is erased is not gone. Somewhere, within that infinite compression, every detail still exists. The echo of every star, every molecule, every thought waiting, perhaps, to be read again when the universe finally learns how to see its own reflection. The universe feels solid. We reach out and touch the world, and it pushes back. Mountains rise, oceans surge, planets orbit, and galaxies swirl in their vast and luminous order. Everything appears to exist in depth and substance. But what if that sense of depth is an illusion? What if the three-dimensional universe we live in is not the full reality, but a projection, a shadow of something deeper, inscribed on the edges of space itself? This is the heart of the holographic principle. The idea that everything we experience, from the smallest particle to the grand sweep of galaxies, might be encoded on a distant cosmic horizon, like a film projecting the story of existence into the vast interior of space-time. The inspiration for this idea began at the edge of black holes. In the 1970 seconds, physicists discovered something strange. The amount of information a black hole could contain didn't depend on its volume, as you might expect, but on the area of its surface. The more massive the black hole, the larger its event horizon, and the greater its capacity for information. It was as if all the data about what had fallen in stars, planets, light, was not stored inside, but smeared across its surface like an intricate cosmic engraving. That realization shook the foundations of physics. If black holes, the densest objects in the universe, encode their information in 2 dimensions, could the same be true for the universe itself? Imagine standing in a darkened room, surrounded by the shimmering image of a hologram. The picture has depth. You can move around it, see its contours, the illusion of 3-dimensional form, but in truth, all the information is contained on the flat surface that produced it. The 3rd dimension is not a place but a pattern, a translation of 2-dimensional data into a form your eyes and mind can perceive as volume. Now, stretch that metaphor to the scale of the cosmos. The stars, the galaxies, even your body and mind might be part of a similar projection, a vast holographic image cast from the universe's outer boundary. What feels like reality could be the unfolding of information encoded far beyond our reach. This idea does not make the universe any less real. It simply suggests that its reality is built differently than we imagine. According to the mathematics, every particle, every vibration of energy within spacetime corresponds to information written on that cosmic horizon. It is as if the universe is a great library, and we are the stories being read from its walls. The notion is so counterintuitive that it almost feels mystical, yet it arises from the most rigorous attempts to reconcile quantum mechanics and gravity. When the two are forced to coexist, they hint that space itself may not be continuous but discrete, made of tiny quanta of information woven together like threads of code. We are patterns in that code, conscious expressions of data moving through the simulation of depth. In this view, the universe is not an object but a computation, an unfolding of equations that create the illusion of motion, structure, and time. Every event that happens, every particle that collides, is part of that calculation. The speed of light, the strength of gravity, the quantum behavior of matter, all are constraints written into the holographic fabric. Even time itself may not flow the way we perceive it, but could be an emergent property, a rhythm produced by the processing of cosmic information. In that sense, the universe might not be something happening around us, it might be something happening through us. It's easy to imagine this as a cold mechanical truth, a cosmic simulation humming away beyond comprehension. But in another light, it's almost poetic. If everything we see and feel is encoded on the universe's horizon, then we are each fragments of a greater design. Our experience is linked by the same fundamental script. Every atom in your body, every thought that crosses your mind, is part of a seamless pattern etched into the cosmos. You are, in the most literal sense, written into the universe. The holographic principle also offers an unexpected kind of comfort. It tells us that even when matter disintegrates, when energy disperses, the information remains. Nothing is truly lost, only transformed, translated into new expressions of the same underlying code. When a star burns out, its pattern is not erased. It becomes part of the next layer of the hologram. When you breathe, when you speak, when you dream, you are adding new sequences to that endless record. The universe remembers everything, not in the fragile way that we remember, but as structure itself. If you could somehow step outside the hologram and look at it from its edge, you might see all of history, the birth of galaxies, the rise and fall of civilizations, the pulse of countless lives unfolding as a single timeless design. Every point of light you see in the sky could be both near and far, both past and present, projected from the same luminous boundary. The illusion of distance, of motion, of change would dissolve into a single truth, that everything is connected because everything is one. Perhaps the universe is not a machine but a memory. Perhaps what we call reality is the act of reading that memory, line by line, moment by moment. The stars above, the atoms within, the invisible threads of gravity that hold them together, all might be symbols on a cosmic surface, so vast we can only experience it from the inside. And somewhere, written into that grand hologram, is the faint but persistent truth that what we call the world is not a prison of matter but a masterpiece of light. At the center of almost every galaxy, including our own, there lies something both terrifying and vital. A supermassive black hole, millions or even billions of times heavier than the sun. It is the dark heart around which everything else revolves, the silent engine that gives a galaxy its rhythm. These titanic objects are not mere destroyers, they are architects. They feed, they rest, they pulse. In their strange, unseen way, they breathe life into the cosmos. When you look up at the Milky Way on a clear night, that pale river of stars flowing across the sky seems calm and eternal. But hidden at its center, behind veils of dust and light years of space, is Sagittarius A*, a supermassive black hole about 4 million times the mass of our sun. It sits like a beating heart at the galaxy's core, shaping the motion of hundreds of billions of stars, holding together a system vast beyond comprehension. And though it appears still, it is anything but. Sometimes, it flares brief bursts of X-rays and radio waves, like the quickened pulse of something immense. For decades, astronomers thought black holes were purely destructive, consuming everything within reach. But as our telescopes and models grew sharper, a new picture emerged. The energy released as gas and dust spiral inward doesn't simply vanish, it radiates outward, sometimes violently. As matter falls into the black hole's accretion disk, it heats to millions of degrees, glowing with fierce light and hurling jets of plasma thousands of light years long. These jets can punch through the galactic medium, stirring gas clouds, triggering new waves of star formation, or snuffing them out. The black hole is both creator and regulator, a sculptor that uses gravity as its chisel. In this sense, galaxies are not just clusters of stars, they are ecosystems, and their supermassive black holes act as central organs, maintaining balance. When the black hole feeds, its energy can suppress the birth of new stars by blasting away the gas that would form them. When it sleeps, the galaxy can grow again, filling the void with fresh generations of suns. This cycle of consumption and creation gives galaxies their long-term stability, keeping them from collapsing under their own weight or burning out too quickly. It is a cosmic metabolism, a heartbeat that spans billions of years. Some black holes are gluttonous, devouring matter at furious rates and shining brighter than entire galaxies. These are quasars, blazing lighthouses visible across the universe. Their light took billions of years to reach us, meaning we see them as they were in the young cosmos, black holes in their wild youth, shaping galaxies just being born. The radiation and winds they emit can clear entire regions of space, regulating the growth of stars like gardeners, pruning a cosmic forest. Others, like the one at our own center, are quieter, resting between feasts. Their glow dim, but their influence ever present. Even in stillness, they guide the dance of the stars. It's strange to think of something defined by absence, by an event horizon that allows nothing to escape, as being essential to the structure of everything. Yet without these dark anchors, galaxies might never have formed at all. Early in the universe's history, when gas and dust were still settling from the Big Bang, tiny black holes may have provided the seeds around which matter gathered, giving shape to the first galaxies. Their gravity pulled in clouds of hydrogen, compressing them into the first stars, igniting the first light. From then on, the growth of black holes and galaxies became intertwined, each feeding the other in a cosmic feedback loop that continues to this day. You could say the universe itself breathes through them. Galaxies inhale, drawing gas inward, forming new stars, and then exhale through their black holes, releasing energy, regulating, maintaining equilibrium. These pulses can take millions of years, but on the scale of the cosmos, they are as steady as the rhythm of a living being. When we look across the universe, we see galaxies flickering in and out of brightness, as if the cosmos itself is breathing through billions of luminous lungs. Even our own existence owes something to this balance. The heavy elements that make up our planet, iron, carbon, oxygen, were forged in generations of stars, whose births and deaths were guided by these central forces. Without black holes moderating the pace of galactic evolution, the universe might have burned too fast or remained too cold and diffuse for life to ever emerge. In a way, the same gravity that pulls light into darkness also paved the way for consciousness to awaken and look back in wonder. Astronomers now listen to these galactic hearts with instruments that can detect their subtle tremors, ripples in spacetime, called gravitational waves, born from black holes merging in slow, cataclysmic embraces. Each wave that reaches us is like the echo of a heartbeat felt across billions of light years, a vibration from the skeleton of the cosmos itself. It reminds us that even the deepest darkness moves with purpose, that even silence can have rhythm. At the center of every galaxy, the story repeats. Darkness surrounded by light, chaos balanced by creation, destruction entwined with order. The black hole is not a villain in this story, but a composer, conducting the cosmic symphony in movements too vast for us to hear. Galaxies drift and spin, stars ignite and fade, and through it all, the heart at the center beats slow, powerful, eternal, keeping time with the pulse of the universe. The universe, vast and seemingly silent, is never truly still. Beneath the stillness, space itself shivers with memory. Invisible waves ripple through the fabric of reality, stretching and compressing it in rhythms older than galaxies. These are gravitational waves, distortions born from the most violent moments the cosmos has ever known. The collision of black holes, the merging of neutron stars, the trembling aftermath of creation itself. They are the faintest of echoes, yet they carry the stories of events so immense that light itself cannot reveal them. Where light is scattered or swallowed, these waves move freely, whispering through space-time long after the flames of their birth have gone cold. For a century, they existed only as a theory. Einstein predicted them in 1916, a consequence of his general relativity, though even he doubted they could ever be detected. They were too subtle, their effects too delicate. A passing gravitational wave would change the distance between 2 points by less than the width of an atom. Even across kilometers of space, detecting such a shift seemed impossible. And yet, 100 years later, humanity built the instruments that could listen for them. Massive laser observatories like LIGO and Virgo, silent cathedrals of precision built to measure the faint tremors of spacetime. In 2015, the universe finally spoke. The signal was faint, almost a murmur. Two black holes spiraling toward each other over 1 billion light-years away, their final collision sending out ripples through the cosmic sea. For a fraction of a second, Earth quivered space itself, expanding and contracting imperceptibly as the waves passed through. It was the first time we had ever heard the universe, the first time we had felt its pulse directly through the curvature of reality. That single detection confirmed not only Einstein's vision, but also our connection to events across unimaginable distances. These waves do not carry light or matter, only the rhythm of movement itself. They are pure geometry, vibrations of space-time, the universe's way of remembering motion. When two massive objects orbit one another, their dance stirs the fabric around them, like pebbles dropped into a pond. But unlike ripples on water, gravitational waves do not fade quickly. They travel endlessly, undistorted, carrying with them the shape and tempo of the event that created them. A black hole collision becomes a kind of cosmic drumbeat, its final moments echoing across eons. Each wave tells a story written in gravity's language. The pitch of the wave reveals how massive the objects were. The rhythm tells how they moved before their merger. The fading tone, their final union. From these patterns, physicists can reconstruct what no telescope could ever see: a map of invisible cataclysms. The first detections revealed pairs of black holes so massive and so distant that they had been silent ghosts to every other instrument. Later, new signals brought us the song of neutron stars colliding, a gentler but richer melody that not only rippled space but filled it with light. That collision scattered gold and platinum through the cosmos, the very atoms in our rings and circuitry, born from such moments of violence and beauty. Gravitational waves have since become a new kind of astronomy, one that listens rather than looks. Through them, we can detect what light cannot escape from: the births of black holes, the slow waltz of spinning stars, perhaps even the faint tremors from the first moments after the Big Bang. In theory, the entire universe should still hum faintly with those primordial waves, the echoes of creation itself, frozen in space-time since the instant matter began. They would be the oldest sound in existence, a cosmic heartbeat that has never stopped. The concept is almost spiritual in its simplicity. Every collision, every motion of immense mass leaves a lasting mark on the structure of space. The universe is not indifferent, it remembers. The fabric of reality holds the imprint of everything that has ever happened, woven into its tension and release. When we detect gravitational waves, we are not just recording distant events, we are touching the memory of the universe itself. We are feeling its vibrations through time. The waves move at the speed of light, yet they are not light. They pass through galaxies, stars, even us, without resistance or sound. They are silent to our ears, but if we could translate their frequencies into tones, the cosmos would sing with an endless symphony, a low, shifting choir of mergers and collisions, of beginnings and endings. Every galaxy would contribute a note, every black hole a rhythm, every interaction a resonance. To listen would be to hear the heartbeat of everything. In the faint signals captured by our instruments, we find proof that the universe is dynamic, alive, and profoundly connected. Every ripple we detect ties us to something vast and ancient, something that transcends light, matter, and time. The black holes that merged billions of years ago did not know we would someday listen, yet their motion wrote a message that would reach us across the ages. And in deciphering that message, we realize that creation never truly ends, it reverberates, again and again, through the fabric of being. We live, quite literally, inside those echoes. Every atom, every movement, every heartbeat on Earth vibrates within the same cosmic ocean, stirred by forces older than our galaxy. And as our instruments grow more sensitive, As we tune our hearing to the universe's deeper harmonies, we may one day listen back far enough to catch the first tremors, the moment when existence itself began to hum. There is a region around a spinning black hole where the universe itself cannot stand still. It is not inside the event horizon, yet nothing within it can remain motionless relative to the distant stars. This place is called the ergosphere, a warped, spinning halo of space, where the black hole's rotation drags everything around it, including light, energy, and time itself. To enter this region is to step into a cosmic whirlpool, where the fabric of reality is twisted into a spiral and motion becomes inevitable. Most black holes rotate. When a massive star collapses, it rarely does so without spin. Its angular momentum is conserved, concentrated into the infinitely small singularity at its core. The result is a rotating black hole, known as a Kerr black hole, a creature that does not simply pull inward, but also swirls, its gravity and spin entangled in a mesmerizing dance. Unlike the still, spherical void of a non-rotating black hole, a Kerr black hole is an engine of motion. Its spin deforms spacetime into a vortex, a kind of gravitational storm that can twist light into loops and pull even time into rotation. Inside the ergosphere, the rules of motion change. Because space itself is dragged around by the black hole's spin, a phenomenon known as frame dragging, no object can resist the pull. Even if you fired rockets at full power, you could not stay still, relative to the universe beyond. Everything must move, not because of an external force, but because the coordinates of space themselves are turning. It is as if reality has been caught in a current, and you are a leaf floating on its surface. To visualize it, imagine stirring a spoon in honey. The honey near the spoon twists with it, while the outer regions move more slowly. Around a rotating black hole, space-time behaves like that honey. The closer you approach, the stronger the spin, until near the event horizon, the dragging becomes absolute. The ergosphere lies between these two regions, a boundary where the spin of space-time reaches its fever pitch, but has not yet vanished into the point of no return. Within this zone, the difference between motion and stillness dissolves. Yet this swirling chaos hides a remarkable secret. The ergosphere is one of the few places in the universe where energy can be extracted from a black hole. In 1969, physicist Roger Penrose proposed a daring idea. If an object were to enter the ergosphere and split into two parts, one falling into the black hole, the other escaping, then the escaping piece could leave with more energy than it arrived with. The black hole's rotation would slow slightly, its spin converted into usable power. It was the first theoretical example of how something could take energy from a black hole without violating the laws of physics. This process, now called the Penrose mechanism, opened the door to an astonishing idea. Black holes are not just consumers but potential sources of energy, cosmic turbines that spin with unimaginable force. Later theories expanded on this, suggesting that magnetic fields near the ergosphere could twist and channel some of that rotational energy outward, powering the enormous jets of plasma that shoot from the poles of active galaxies. These jets can extend for millions of light years, lighting up the darkness like cosmic beacons. What we see as violent radiance from the hearts of quasars may, in truth, be the byproduct of black holes sharing a fraction of their spin with the universe. The implications reach far beyond astrophysics. The ergosphere blurs the line between energy and motion, between gravity and time. Inside it, the direction of cause and effect is warped by rotation. To move against the spin is to move backward through a distorted version of time. To move with it is to ride the current of the cosmos itself. Light, too, is caught in this dance. Rays emitted against the spin lose energy, reddened and stretched, while those aligned with it are accelerated, bluer and brighter. Space is no longer a passive stage, it has become an active participant in motion. If you could hover safely within the ergosphere, you would see a world that defies intuition. Stars behind you might appear to streak and smear across the sky, bent by gravitational lensing. The black hole itself would not be a simple circle of darkness, but an ovoid whirl, its shadow compressed by rotation. Time would stretch unevenly, your seconds slipping differently from those of a distant observer. You would be inside the eye of a storm that reshapes causality, watching the universe whirl around a singular point that neither space nor time can describe. And yet, within that storm, there is harmony. The ergosphere is a perfect compromise between gravity and motion, where the violence of collapse gives birth to the elegance of rotation. It is the region where entropy meets order, where even destruction becomes productive. Every rotation feeds the jets that shape galaxies, the magnetic fields that light up the void, the energy that cycles back into creation. The universe wastes nothing, not even its darkness. In the ergosphere, you can feel the pulse of that truth. The black hole spins, space-time turns, and everything caught within must move. But in that movement lies balance. Even as light bends and time distorts, energy flows outward. The universe breathes through the black hole's spin, and the ergosphere is its inhalation, a moment where darkness and motion blur together to sustain the rhythm of existence. For most of a century, physicists imagined falling into a black hole as a strangely uneventful experience, at least until the end. According to Einstein's general relativity, once you crossed the event horizon, nothing remarkable would happen at first. Space would curve gently, light would dim, and gravity would stretch you more and more as you approached the singularity. But there would be no violent boundary, no sudden barrier of force. To the falling observer, the horizon was just another patch of space-time. The real destruction lay far ahead, deep inside. But in the past decade, that serene picture has been shaken by a bold and unsettling question. What if the horizon isn't so peaceful after all? What if, instead of a quiet crossing, it's a wall of fire? The idea emerged from one of the most persistent puzzles in theoretical physics, the black hole information paradox. According to quantum mechanics, information can never be truly lost. Every event, every particle interaction leaves an imprint on the universe that must somehow persist forever. But black holes seem to defy this rule. When they swallow matter, all distinctions between what fell in stars, planets, or entire galaxies are erased. Hawking radiation slowly leaks energy back into space, but that radiation appears random, devoid of the information it once contained. By the time the black hole evaporates, the data describing what it consumed would seem to be gone forever, breaking the fundamental laws of quantum theory. Physicists have spent decades trying to reconcile this contradiction, and from those debates, a radical new idea was born. Maybe the event horizon itself burns. Maybe it's not the smooth, gentle boundary that relativity describes, but a seething, incandescent barrier where the laws of physics collide. This is the so-called firewall hypothesis, a concept so extreme that it challenges both general relativity and quantum mechanics at their foundations. The logic behind it is simple, yet devastating. If information truly escapes from a black hole through Hawking radiation, then that radiation must somehow carry details about what fell in. But quantum mechanics forbids information from being duplicated. It can't exist both inside the black hole and outside in the radiation at the same time. Something has to give. One possible solution is that the interior doesn't exist at all in the way we think it does, that the infalling information is instantly destroyed at the horizon, converted into a burst of pure energy. Instead of slipping gently through, you would hit a wall of unimaginable heat, a blaze formed by the quantum entanglement of the universe itself unraveling at the edge. If the firewall exists, it would mean Einstein's cherished principle of equivalence. The idea that free fall feels the same everywhere breaks down at the horizon. The calm, seamless crossing he predicted would be an illusion. The black hole would no longer be a gateway to deeper space, but a cosmic incinerator. Space and time would end not at the singularity, but at the edge, where the quantum world demands its price. But many physicists refuse to believe that. The equations of relativity have passed every test thrown at them, and they tell us that an observer crossing the horizon should feel nothing special. To them, the firewall feels like a violation of nature's deeper symmetry, a betrayal of the elegance that the universe has shown in every other context. They argue that the paradox must be resolved some other way, that information is preserved, not by destruction, but by subtle correlations spread across the black hole's surface. In that view, the horizon is not a furnace, but a hologram, a thin quantum layer that encodes everything that ever fell in, perfectly, balanced between gravity and information. It's possible that both pictures are true, depending on who's looking. To a distant observer, watching from outside, the horizon may appear fiery and impenetrable, a surface glowing with energy as it radiates information back into the universe. But to the falling observer, reality could remain smooth and quiet, the crossing uneventful until the final approach to the singularity. Two perspectives, both correct within their own frames, divided by the strange logic of quantum relativity. The universe might allow both to exist, no contradiction, just a difference of perception written into space-time itself. This is what makes the firewall debate so haunting. It's not simply about black holes. It's about the limits of knowledge, the point where even our best theories refuse to agree. If the horizon burns, then the universe hides its truths behind pain and finality. If it doesn't, then there must exist a deeper harmony, one we have not yet glimpsed, where gravity and quantum theory finally reconcile. Either way, the answer will reshape everything we know about space, time, and the nature of reality. If you could hover above that boundary, watching matter fall inward, you'd see it stretch and redden, fading as time itself slowed. But you might also see something else: tiny flashes, quantum sparks, where the fabric of the universe negotiates between destruction and preservation. To us, it would be chaos, but perhaps to the black hole, it would be order, the steady flow of information being rewritten in a form we cannot yet decode. In the end, the question of the firewall may remain unanswered for generations. It's a riddle whispered by the universe itself, a choice between smoothness and fire, between elegance and violence, between what we can imagine and what we can never truly experience. Perhaps the horizon is both, a place of annihilation and preservation, where energy burns bright to protect the laws of information, and yet, beyond the flame, space-time continues in silence. Perhaps, as with everything else in the cosmos, the truth is not a wall, but a paradox, a boundary that both exists and dissolves, flickering at the edge of what we can ever know. For most of the 20th century, black holes were imagined as eternal. Once they formed, nothing could unmake them. They would sit at the heart of galaxies, swallowing light, devouring stars, and growing endlessly in their perfect, featureless darkness. They were the universe's final word on gravity, places where everything ended and nothing could escape. But in 1974, a young physicist named Stephen Hawking discovered that even black holes, those icons of permanence, could die. His revelation began not with an explosion, but with a whisper, a faint, invisible hiss of energy leaking from the edge of the abyss. It began with a question. Hawking was studying quantum fields near the event horizon, the boundary around a black hole where gravity becomes irresistible. Classical physics said that once something crossed that horizon, it was gone forever. But quantum mechanics paints a more restless picture. Even in the emptiest void, space isn't truly empty. It seethes with activity, virtual particles flickering into existence in pairs, borrowing energy from the vacuum before annihilating each other almost instantly. Hawking wondered what would happen to those pairs near the edge of a black hole. What if one particle fell in while the other escaped? In that moment, something extraordinary emerged. The particle that escaped would carry energy away, while its partner, trapped inside, would effectively reduce the mass of the black hole. To an outside observer, it would seem as though the black hole were emitting radiation light from nothing, warmth from the coldest place in the universe. The impossible had happened. A black hole could leak energy. It could shrink. It could die. This faint glow, now known as Hawking radiation, changed everything. It revealed that black holes are not the end of the story, but part of a cosmic cycle. They can form, evolve, and eventually evaporate, returning their energy to the universe. Over unimaginable timescales, trillions upon trillions of years, a black hole will radiate away its mass, becoming smaller, hotter, and brighter as it approaches its final moments. What was once the ultimate consumer becomes a source of light, a dying ember in the long night of time. The physics behind this process is astonishingly subtle. The radiation doesn't come from within the black hole itself, but from the space just outside it. The horizon acts as a kind of membrane, a stage where quantum fields interact with gravity in their most extreme form. The escaping particles are not torn out from inside but born at the edge, their existence owed to the strange interplay between uncertainty and curvature. It's as if the black hole's boundary is constantly whispering, releasing tiny packets of information into the void messages from the brink of nothingness. That whisper is unimaginably faint. For a black hole the mass of the sun, the radiation temperature would be a fraction of a microkelvin, far colder than the background glow of the universe. Detecting it directly is almost impossible. And yet, the mathematics leaves no room for doubt. Every black hole, from the smallest to the supermassive, radiates. Every one will someday fade. The monsters that once terrified us are not immortal after all. They too will surrender to time. Hawking's discovery did more than reveal the mortality of black holes. It united two seemingly opposite worlds. It brought together the smooth geometry of Einstein's relativity and the jittery probabilities of quantum mechanics, showing that even the most extreme gravity cannot silence quantum behavior. The event horizon, once thought to be the perfect divider between the known and the unknowable, became a part, a living surface, humming softly with the fluctuations of the vacuum. It was the first real glimpse of a bridge between the great theories of physics, a hint of a deeper, unified law, still waiting to be understood. In the far future, long after the last stars have burned out and galaxies have dissolved into darkness, black holes will be the final actors in the cosmic drama. They will dominate the night, slowly evaporating as their horizons shrink. The largest will linger longest, their lifespans stretching far beyond the current age of the universe. But even they will not last forever. As they near the end, their temperature will climb, their radiation intensifying until, in a single final flash, they release everything they once consumed. The universe will end not with silence, but with a faint and fading chorus of Hawking whispers, each black hole singing its final note into eternity. There is something poetic about this, something deeply human. Hawking himself spent much of his life in stillness, confined by illness, speaking through a voice that was soft and deliberate, yet filled with fire. His work gave voice to the most silent of cosmic beings, revealing that even the darkest things emit light. He showed us that nothing, not even a black hole, is truly isolated. Everything participates in the exchange of energy, the conversation of the universe. In that sense, Hawking's radiation is more than a physical process. It is a symbol of persistence, the idea that even where all seems lost, some trace remains. The universe does not end in finality, but in transformation. The same force that devours stars eventually gives back its warmth, whispering to the void that nothing, not even darkness, lasts forever. And so the black hole, once feared as the grave of all things, becomes something gentler, a fleeting shimmer of light at the edge of time, proof that even in the deepest silence, the universe still finds a way to speak. Every ending in the universe is the beginning of something else. Even the death of a star, an event so violent it reshapes the very atoms of existence, does not mark a true conclusion. It is a transformation. In its final breath, A massive star can give rise to a black hole, an object so dense that it traps not only light, but the story of everything that came before. And yet, in an astonishing cycle, those same black holes can shape the birth of new stars, new worlds, perhaps even new forms of life. The cosmos, for all its destruction, is a master of renewal. The process begins deep within the heart of a living star, where gravity and fusion balance in perfect tension. For millions or billions of years, the star burns hydrogen into helium, then helium into heavier elements, carbon, oxygen, iron, each reaction feeding the next, each step a little harder to sustain. But there comes a point when the star's core fills with iron and the furnace goes cold. Iron cannot burn, it cannot yield energy through fusion. In that instant, the delicate equilibrium collapses. Gravity, which the star has spent a lifetime resisting, takes over. The outer layers plummet inward, smashing into the core at a fraction of light speed. The result is a supernova, one of the most powerful explosions in nature. For a few seconds, the star outshines entire galaxies, releasing more energy than our sun will produce in its entire lifetime. Its outer shells are blasted into space, scattering the elements forged in its heart: carbon for life, calcium for bones, gold for blood, iron for planets across the void. Everything we are was born in such a death, but at the center, something stranger happens. The imploding core, too dense to become a neutron star, collapses beyond measure, folding itself into a singularity. A black hole is born. From that moment, it becomes an engine of gravity, a silent anchor for the surrounding chaos. The explosion that created it also leaves behind vast clouds of gas and dust, debris that cools and condenses over time. The black hole's gravity tugs on this material, drawing it into swirling disks, heating it through friction until it glows. These accretion disks can shine brighter than entire star clusters, radiating across the universe. And within those chaotic disks, something unexpected happens. The same compression and turbulence that feed the black hole can also trigger new waves of star formation. In this way, a single stellar death can lead to the birth of countless new suns. Even on a galactic scale, black holes are agents of creation. The supermassive ones that lurk at galactic centers regulate the rhythm of star birth across billions of light years. When they feed, they release titanic jets of energy that sweep through their host galaxies, heating gas and halting the formation of new stars. When they rest, that same gas cools and collapses again, igniting fresh generations. It is a cosmic breathing, inhale, exhale, written in light and gravity. Destruction becomes nourishment, violence becomes balance. This cycle is not gentle, but it is elegant. Every black hole exists because something once lived and burned brightly. And though they consume, they also give back through the structures they shape and the forces they command. Without them, galaxies might never have organized themselves into the grand spirals and clusters we see. The material they expel and stir becomes the raw substance of new worlds. In a sense, black holes are both graves and wombs, final resting places for matter, and cradles for what comes next. If you could trace the atoms in your body back through time, you would find that many were forged in the core of a massive star that died long before the Earth existed. Some might have passed near the event horizon of a black hole, their paths bent and altered by gravity before drifting into new clouds of dust that would one day form our solar system. The calcium in your bones, the iron in your blood, the gold on your finger, they are the ashes of ancient suns, scattered by explosions and sculpted by the pull of invisible giants. You are, in every sense, recycled starlight. And perhaps, far in the future, the cycle will continue. The stars we know will burn out and die, collapsing into black holes of their own. Over billions of years, those black holes will merge, consuming and reshaping the universe's structure. Their radiation will leak into the dark, their spin will slow, and their energy will seed whatever follows. New stars may rise from the remnants, faint at first, then growing, illuminating the ruins left behind. The cosmos does not waste it, rearranges. There is a strange comfort in knowing that even the darkest forces in the universe participate in this act of renewal. Black holes, for all their appetite, are part of a system that sustains itself. Life too follows that same rhythm: birth, death, transformation. The atoms that once pulsed in the heart of a distant sun now think, breathe, and dream within us. One day, they will return to the stars, to be reborn again in some future world. In the grand tapestry of the cosmos, nothing truly ends. Stars die to create black holes. Black holes feed the birth of stars, and everything that exists is part of the same unbroken exchange. The universe recycles itself endlessly, turning loss into creation, silence into light. Even in its darkest depths, it is not a place of endings, but of return, a vast and patient garden, forever blooming from its own ashes. Black holes, by their very nature, cannot be seen. They emit no light, reflect nothing, and hide their presence behind a boundary from which even information cannot return. And yet, despite their invisibility, humanity has found ways to glimpse them, to sketch their outlines, using the light of everything they touch, the radiation of matter they consume, and the distortions they leave imprinted on the fabric of space. It is one of science's most profound ironies. The darkest objects in the universe revealed through the brilliance they create around themselves. For most of history, black holes were theoretical phantoms, invisible predictions that haunted equations but not telescopes. Astronomers knew they must exist. Stars orbited invisible partners, galaxies spun as though anchored by unseen giants, but no one could prove it. The light that could tell their story never escaped. So scientists learned to look for their absence instead. A star flickering oddly, gas moving too fast, radiation bending at strange angles, each became a clue. Black holes announced themselves not by what they showed, but by what they stole. As technology advanced, so did our vision. In the middle of the 20th century, radio astronomy opened a new window onto the cosmos. Where visible light revealed stars and galaxies, radio waves showed something stranger. Vast jets of energy streaming from galactic cores, brighter than all their stars combined. These jets could not come from ordinary processes. They were too powerful, too focused, too continuous. The only explanation was the presence of supermassive black holes, drawing in matter and flinging part of it outward at nearly the speed of light. Though the black holes themselves remained invisible, their influence painted the sky in long, invisible strokes of radio light. Later came X-ray observatories, orbiting high above Earth's atmosphere where such radiation could be detected. These instruments revealed black holes in their feeding frenzy, their accretion disks glowing at millions of degrees as they devoured gas and dust. Each flash of X-rays was a scream of matter spiraling toward oblivion, energy released in its final moments of freedom. Binary star systems provided some of the clearest evidence. In Cygnus X1, for instance, a bright star orbits an unseen companion that emits intense X-rays. The star's outer layers are being stripped away, drawn toward an invisible point so dense and so small that no other explanation fits. We cannot see the black hole, but we can watch its hunger, its effect on everything near it. Still, astronomers wanted more than inference. They wanted to see the unseeable, and so began one of the most ambitious projects in human history, the Event Horizon Telescope. Rather than a single telescope, it is a network, a collaboration of observatories scattered across the planet, synchronized with atomic precision. By linking them together through a process called interferometry, scientists effectively created a telescope the size of the Earth itself. Only such an instrument could resolve something as small and distant as the shadow of a black hole's event horizon. The target was the supermassive black hole at the center of the galaxy M87, 55 million light-years away. For years, Teams of scientists captured data at millimeter wavelengths, recording petabytes of information on hard drives flown between continents. Then came the reconstruction, an enormous computational puzzle, turning streams of data into an image. What emerged in 2019 stunned the world. A ring of fire encircling a dark center, the first direct glimpse of a black hole's silhouette. It was not an artist's impression, not a simulation, but a photograph of reality itself, the shadow cast by gravity on the fabric of spacetime. Humanity had finally mapped the invisible. That image was more than proof of existence. It was a revelation of structure. The ring's brightness, asymmetrical and glowing, revealed the rotation of the black hole and the direction of matter swirling around it. The size of the shadow confirmed Einstein's predictions with breathtaking precision. For the first time, we saw not just theory, but geometry made real, the way light bends, the way time curves, the way the universe shapes itself around an abyss. The same methods have since turned toward our own galactic center, Sagittarius A*A, quieter black hole 4 million times the mass of the Sun. Capturing its image was even harder. Gas clouds blur its outline, and its activity shifts minute by minute. Yet even there, the faint structure emerged. Another glowing ring, another dark heart. Each observation refines our understanding of how black holes feed, spin, and interact with their surroundings. What was once only mathematical abstraction now flickers before us, glowing faintly in wavelengths our eyes cannot see. But perhaps the most haunting part of these discoveries is not what we see, but what they imply. Every image, every spectrum, every pulse of radiation tells a story, not only about the black hole itself, but about the light it devours. The glowing rings are the ghosts of photons that almost escaped, their paths curved by gravity into endless orbits before surrendering to darkness. What we see is the edge of forever, the final moments of light before it falls out of the universe's conversation. In mapping the invisible, we have not only seen black holes, we have glimpsed the limits of vision itself. Our telescopes do not just collect light, they collect memory. Every wave, every photon, is a survivor of gravity's pull, a fragment of what almost wasn't lost. Through them, we have learned that the universe hides nothing maliciously. Even its darkest places shine, if you learn how to listen. The black hole, once a symbol of absence, has become a mirror showing us that even invisibility can leave an imprint, and that to see truly, one must look beyond the light. At the heart of nearly every galaxy lies a monster, a supermassive black hole, millions or even billions of times heavier than the Sun. These titans are the quiet architects of the universe, shaping the rhythm of galaxies, influencing the birth of stars, and weaving invisible threads that link the cosmos together. Though each one is isolated by distance and darkness, they form a hidden network, their gravity and energy resonating across intergalactic space. The universe, it turns out, is not a chaotic scattering of galaxies, but a vast web, its nodes defined by these cosmic giants. The origins of supermassive black holes remain one of the universe's great enigmas. Some may have formed from the collapse of the first star's primordial giants, 1,000 times the Sun's mass that lived short, furious lives and died young. Others might have emerged directly from dense clouds of gas collapsing under their own gravity before any stars existed at all. However they began, their growth was relentless. They fed on gas, dust, and stars, their mass swelling as they consumed everything nearby. Some merged with others during galactic collisions, forming even larger behemoths that anchored their new, combined homes. In the early universe, when galaxies were closer together, these mergers were frequent and violent. As two galaxies collided, their central black holes spiraled toward each other in a slow gravitational dance, warping space-time and releasing ripples known as gravitational waves, vibrations that stretch and compress the very structure of the cosmos. For billions of years, those ripples have traveled outward, faint but unceasing, carrying the story of ancient unions between invisible giants. Every time a galaxy merges, every time a black hole consumes another, the web of the universe tightens, its pattern growing richer and more intricate. As they grow, these supermassive black holes become engines of extraordinary power. When gas falls toward them, it forms an accretion disk that blazes with light, sometimes brighter than the entire galaxy around it. The friction and magnetic fields within that disk twist the material into jets of plasma that shoot from the poles at near-light speeds, extending across millions of light years. These jets regulate the growth of galaxies, heating and dispersing the gas that might otherwise form new stars. In this way, the black holes act as both creators and destroyers, keeping the universe in balance by controlling when and where stars are born. Galaxies and their central black holes grow together, each influencing the other. Observations show an astonishing relationship between a black hole's mass and the velocity of the stars in its host galaxy. Somehow, across unimaginable scales, there is communication between the core and the whole. It's as if each galaxy has a heartbeat, its rhythm set by the black hole at its center. When the black hole feeds, the galaxy brightens with bursts of new star formation. When it rests, the galaxy settles into calm, drifting quietly through the cosmic sea. From a vast distance, the universe resembles a great cosmic web, a network of filaments connecting clusters of galaxies like threads in a three-dimensional tapestry. At the intersections of those threads, where galaxies gather in great clusters, supermassive black holes reign. Their influence extends far beyond their own galaxies, their radiation and gravitational fields shaping the motion of matter on intergalactic scales. Even the dark matter that forms the scaffolding of the cosmos seems to respond to the gravity of these titans, gathering around them like dust swirling toward a drain. Over billions of years, black holes have sculpted the visible universe into the patterns we see today. Without them, galaxies might have grown too large, stars too abundant, and the cosmic balance would have fractured. Their destructive appetite is paradoxically creative. It sets the limits that make structure possible. Every spiral galaxy, every cluster, every luminous arc of stars owes its shape, at least in part, to the silent regulation of the dark heart within. When two supermassive black holes finally merge, the event releases more energy than all the stars in the observable universe combined, though most of it radiates as gravitational waves rather than light. These waves pass through everything, bending time by the width of an atom, yet spreading across billions of light years. They are the faint echoes of creation, the soundless heartbeat of the universe. Modern detectors on Earth, vast laser observatories like LIGO and Virgo, are beginning to hear those ripples, decoding the stories of collisions that happened long before Earth existed. And as we listen, a larger picture is emerging. The universe may not just contain supermassive black holes, it may be organized by them. They define the centers of motion, the nodes of structure, the anchors of time itself. Their mergers shape the destiny of galaxies. Their energy sculpts the flow of matter across cosmic distances. Though separated by inconceivable spans, they are connected by the waves of gravity they send through the fabric of space, bound together in an invisible symphony that plays across the entire universe. We often think of black holes as symbols of isolation endpoints where everything disappears. But the truth is almost the opposite. They are the bridges of the cosmos, the gravitational hubs that keep the universe coherent. Through their gravity, through their energy, through the invisible threads that connect them across time and space, the black holes at the centers of galaxies are not solitary at all. They are part of a vast, silent network, a web of giants that binds the stars, the galaxies, and even the darkness itself into one continuous whole. At the heart of a black hole lies a mystery so profound that even the language of physics falters before it. The singularity, an infinitesimal point where matter is crushed into infinite density, where space and time themselves are twisted into nothingness, marks the limit of everything we know. It is not merely a place where gravity grows strong. It is where our laws of nature, so elegantly precise elsewhere, simply stop working. Beyond it, mathematics loses meaning, and reality dissolves into something we cannot yet describe. And yet, from this void of understanding has sprung some of the boldest and most beautiful ideas in science, visions of tunnels through space-time, of universes budding from within universes, of creation itself, hiding behind the veil of annihilation. When Einstein's equations first predicted singularities, even he did not believe them. He thought nature would find a way to avoid such absurd infinities. But as the equations held up, as observations confirmed the existence of black holes, physicists were forced to confront the possibility that these cosmic abysses were real. Still, there was unease. Infinity is not a number, it is a confession of ignorance, a symbol of something incomplete. To understand what truly lies beyond, we must look to where gravity meets quantum theory, and to the strange possibilities that arise when space-time itself becomes fluid. One of those possibilities is the wormhole, a theoretical bridge connecting two distant regions of space and time. In the mathematics of general relativity, space-time can curve not just into wells, but into tunnels. A black hole could, in principle, form one mouth of such a tunnel, its immense gravity pinching the universe so tightly that it connects to another place or even another universe entirely. The other end, a hypothetical white hole, would be a mirror opposite. Instead of devouring everything, it would expel matter outward in a radiant flow. Together, they would form an Einstein-Rosen bridge, a shortcut through reality itself. It's an idea that feels like fiction, but rests on serious theoretical ground. If wormholes exist, they could make the impossible possible. Instantaneous travel across galaxies, or even movement through time. Yet every attempt to stabilize one ends in paradox. The energy required to hold a wormhole open would have to be negative, something that bends space in the opposite direction of gravity. In theory, quantum fields could produce such exotic energy, but in practice, the slightest fluctuation would cause the tunnel to collapse. Anything entering would be crushed before it could cross. The universe, it seems, is reluctant to let us cheat its geometry. Still, physicists dream. Some theories suggest that the singularity at the center of a black hole may not be an end, but a transition. When matter collapses beyond the event horizon, it could reach a point where gravity becomes so intense that space doesn't tear, it rebounds. Instead of destroying everything, the singularity could trigger a bounce, expanding into a new region of space-time on the other side. To an observer outside, the black hole would simply evaporate over eons, fading quietly from view. But inside, a new universe might bloom, a baby cosmos, sealed off from ours, growing in its own dimension. Every black hole, in this view, could be the seed of another universe, just as ours might have been born from one before it. It's an audacious thought, that creation and destruction are the same act, seen from different sides of the cosmic curtain. When a star dies, it collapses into a black hole here, but perhaps bursts as a big bang somewhere else. Energy never vanishes, it transforms. From our perspective, a black hole is a prison. From another's, it may be a cradle. Quantum mechanics hints at even stranger things. Space itself, at the smallest scales, may be a froth of tiny wormholes, constantly forming and vanishing in the quantum foam. The universe might be threaded with these microscopic tunnels, linking every region to every other in ways we can scarcely imagine. The singularity, then, could simply be where that quantum geometry knots too tightly for classical space to exist. Beyond it lies not nothingness, but another order of being one. We are only beginning to glimpse through mathematics, through theory, through imagination. If we could somehow peer beyond the singularity, perhaps we'd see the birth of new physics, dimensions curling into themselves, time reversing and restarting, energy becoming structure. It would be the ultimate act of recycling the universe, folding inward to create new versions of itself, endlessly renewing across infinite scales. Perhaps this is why the cosmos is so good at hiding its deepest truths. They are not meant to be contained within one universe alone. In the end, what lies beyond the singularity remains unknowable, at least for now. It may be a gateway, or a wall. It may be chaos or genes. What we do know is that the question itself drives us forward. The search for what lies beyond the event horizon is the same search that led us to the stars, to the atom, to the edge of time. It is the desire to understand what cannot yet be seen, to trace the faint whisper of meaning through the darkest silence of the cosmos. Perhaps someday, when our physics has evolved beyond its current limits, we will learn that the singularity is not the end of reality, but its most concentrated expression, the universe folding back upon itself, dreaming of what it might yet become. There is a strange kind of light that only reveals itself when we look into darkness. It is not the light of stars or fire or fusion, but something quieter born of thought, of curiosity, of the human need to understand. Black holes, the darkest objects in existence, have become the brightest mirrors for that light. In them, we see the limits of our knowledge, the fragility of our laws, and the unyielding persistence of wonder. They are the universe's great paradoxes, places where everything ends, yet somehow everything continues. For centuries, darkness meant ignorance. The night sky was a void until we filled it with meaning, until our instruments turned its silence into data, its emptiness into revelation. Black holes take that old metaphor and fold it inside out. They are darkness as knowledge proof that even the most forbidding parts of the cosmos can teach us something profound about ourselves. They remind us that what we cannot see still exists, that invisibility is not absence, and that understanding sometimes begins where vision ends. We began by imagining them as monsters, cosmic abysses that swallowed everything, erasing light, time, and memory. But as our understanding deepened, we discovered something unexpected. Black holes do not destroy the universe. They organize it. Their gravity holds galaxies together. Their energy regulates star formation. Their existence shapes the structure of space itself. Even their decay, through Hawking radiation, returns energy to the cosmos. What once seemed like the ultimate symbol of finality has become the engine of continuity. The darkness does not end the story, it keeps it moving. Every photon that grazes a black hole tells a tale of resilience. Some are captured forever, their paths twisted into spirals of oblivion, but others skim the edge, bent and stretched by gravity's pull, escaping outward to carry information about the invisible heart beneath. That faint glow, that whisper of radiation, is the universe's promise that even the darkest places are not silent. There is always something that endures, something that slips through the cracks between annihilation and survival. It is tempting to think of the cosmos as vast and indifferent, but black holes suggest otherwise. They reveal that even destruction follows rules, that even chaos has geometry. There is a quiet order beneath the violence, a mathematical grace in the way matter falls, spins, and vanishes. The universe is not careless. It is precise, intricate, deliberate. Every collapse gives rise to a new balance. Every void hides a possibility. In the endless exchange between light and gravity, something like intention emerges, not a plan perhaps, but a pattern, an intelligence written into the structure of reality itself. And within that pattern, we find ourselves. Every atom in our bodies, every pulse of thought, once belonged to a star that lived and died, and was shaped by forces that black holes now govern. The heavy elements that make us were forged in stellar hearts, and scattered by explosions that sometimes birthed these cosmic wells. We are connected to them, not just by curiosity, but by substance. To look at a black hole is, in a strange way, to look backward into our own origins, to see the gravity that shaped the dust that became our blood. If the universe has a memory, it is written in the curvature of space. The orbits of galaxies, The shimmer of background radiation, the slow whisper of evaporating black holes, all of it is a kind of storytelling. And though one day even the stars will fade, the information they carried will never truly vanish. Quantum theory tells us that nothing is ever lost. Not completely. Every bit of existence leaves an imprint, some trace encoded in the unfolding of time. Even when the last black hole evaporates, releasing its final breath of heat into the dark, that information will persist, spread thin but eternal, woven into the background hum of reality. Perhaps that is the real message of black holes, not destruction, but transformation. They teach us that endings are illusions, that energy and meaning only change form. The matter that falls into them is not gone. It is rewritten, rearranged, reborn in another language of the universe. And so, too, are we. Our lives, brief as they are, ripple outward in ways we may never perceive. Every thought, every act, every bit of curiosity is part of the same exchange that fuels the cosmos. The endless motion from order to chaos, from collapse to creation. When we study black holes, we are not peering into death, but into continuity. They are reminders that there are places in existence where understanding bends but does not break, where light itself can be delayed but never completely destroyed. And perhaps that is what it means to exist, to be both fleeting and infinite, fragile and eternal, bound by gravity, yet free in imagination. In the end, the universe may not end at all, not in any true sense. It may dim, stretch, cool, and dissolve, but the patterns it has woven will remain in some form, echoing faintly through time. The same gravity that swallows light also births it. The same collapse that ends a star may begin a new world. And somewhere, in that endless cycle of darkness and renewal, there is always a flicker of light, of memory, of awareness that escapes the dark and carries on.